Hello students, welcome to our next math lesson. It is dealing with lesson 96, which is dealing with functions and also how to graph those particular functions. And we're going to start on page 497. So if you could please make sure to open your books to page 497, that would be helpful. To start us off, we're going to have a bit of background information establishing here with this paragraph that I'm going to read here. It says, we know that the surface area of a rectangular prism is the sum of the area of its sides. Okay. A cube is a special kind of rectangular prism because it's made up of 6 square faces. That basically means that every single face on a cube is a square. If we happen to know one of the sides of the cube, then we can actually use that information to help us find the total surface area for that particular cube. Now, the table down here kind of gives us a chart of how to figure out those surface areas. So, for example, if one face of the cube is 4 square centimeters and there are 6 faces, that means the surface area is 24 square centimeters. Or if one of the faces is 9 square centimeters and there are 6 faces, that means the total surface area would be 54 square centimeters. And again, the same here. If one of them is 16, the surface area would be 96 and 25, 150. Now, you should notice that with all these numbers here, something is happening with all of these numbers right here in order for us to get all of these numbers right here. And I'm doing the exact same thing every single time. Have you figured out what it is yet? The formula, or the function that we are doing from the previous table, is we're doing this. We're taking the surface area is going to be whatever the angle of one of the faces, area of one of the faces, and we're multiplying it by 6. That's the function, okay? This formula here is an example of a function. What exactly is a function again? A function is a rule for using one number, which is usually an input number, a number that you're putting into it, in order for us to calculate another number. And the number that we get afterwards is called an output number. Okay, so in this particular function, the side area was the input and the surface area was the output. So if we go back real quickly to this previous one, what they're saying is these first numbers here, these are the input. I put in a 4, I did something to the 4, and this was my output. I got 24 as my answer. I put the 9 in, I did something to the 9, my output was 54, and so on and so forth. Okay. Now, we can apply that function rule to find the area of really the surface area of any type of cube. If we know the area of one of the sides, all we have to do is multiply by 6, and that'll tell us what our surface area is, okay? Now, the thing about a function is you have to be able to do the exact same thing to all of your input numbers. You can't just do it to one. So, for example, what we're going to do is we're going to actually find the rule for this particular function here. Okay, and then once we do find the rule, we want to find out what would be the value for m, or the output. What's your output when L, which is your input, is 7? So what I'm going to do is I'm just going to look at the top row right now. So let's say, for example, I put 5 in here, and then I do something to this 5, and I get 20 is my answer. Now, there are a couple options here. I noticed that my number is getting bigger. It went from 5 to 20. So that probably means I'm not subtracting and I'm not dividing, because those usually smaller, getting functions to be smaller. It's probably either going to be an addition or a multiplication. Now, some people might think, well, okay, how about multiplication? Because I know if I take 5 and I multiply that by 4, that gives me 20. And that is true. 5 times 4 does give me 20. So that would work for the first row. But we have to make sure that this function, this multiply by 4, we got to make sure it works for every single function. I don't know if it works for this one because I don't know what this is, but I'm going to come down to this next one. If I plug 10 in there and I do 10 times 4, is that going to give me 25? No, it's not. So even though it works for one row, it doesn't work for the entire function. So that means this cannot be what the rule is. Well, if multiplication didn't work, maybe we're kind of stuck with addition. So what if we do that? Let's take 5, and what are we going to add to 5 in order for us to get 20 as our answer? Hopefully by now we figured that out, that that's going to be 15. So if I take 5 plus 15, that gives me 20. I want to check to make sure, does that work for the rest of them? If I take 10 in here, I do 10 plus 15. Does that give me 25? Yeah, that looks good. If I put 15 in there, 15 plus 15, does that give me 30? Yes. So it looks to me like I found my rule. So when it says find the rule, what I'm going to do is I'm going to take whatever my input is. My input are all the L's. So I'm going to say L. And now what did I do to L? I added 15. So I did L plus 15, and that's going to equal whatever I get for my M. So when it says to write a rule, this is how you would write it. Your first row is your input row. What are you doing to the input in order to get the second row, which is your output? Now that we know what this is, we can go back and plug 7 into that problem. Do 7 plus 15. And when I do 7 plus 15, the math tells me that the answer is 22. So I'm going to put a 22 in this box right there. So I found my rule, and I've also found what the missing value is. Remember, whatever the rule is, it has to work for every single row, not just for one of them. Sometimes, this is the previous problem, sometimes what they'll do is rather than having an output letter here, they will go ahead and write the rule automatically for you. So sometimes it'll be, okay, these are all the L's, and this would be L plus 15. So all you're going to do is take this 5 and plug it in there. 5 plus 15 equals 20. And so you will see it written like this sometimes on your lesson for today. So if you see this, this is nice. They've already given you the rule. Now you just have to use that rule to find the missing number, which we already know is 22. So let's use that information to help us try to find this missing number here. Now, this time it's kind of written horizontally instead of vertically. And if it's ever written horizontally, it just means that the first numbers here, these are all my x's. So x is 2, x is 3, x is 4. So this is my input row right here. This row right here is my output row. This is my output. So it means when I put a 2 in there, I get 4 as an answer. Plug 3 in there, I get 7 as an answer. I need to figure this one out right here. So what I'm going to do is I'm going to take a look at this rule right here. Now, if you remember, this right here means 3 times x, and then we subtract 2. Okay. Some people make the mistake of if they plug 2 in there, they think now this becomes 32. And that's not what it's saying. This is 3 times x. Okay. So what we're going to do is we're going to plug that 2 in there. And remember, when we do order of operations, we do the multiplication before we do the subtraction. So I want to do my 3 times 2 first. So 3 times 2 would get me 6. And then I would subtract 2. That's how I got 4 as my answer. If I plug the 3 in there, I'd go 3 times 3. No, not 33. 3 times 3, which is 9. And we take 9 minus 2. 7 is my answer. So let's use that information here. Let's go ahead and plug 4 into this particular problem now. So if I did that, this would be 3 times 4. So I do 3 times 4, which is 12. Let's get that first, 12. And then I want to take 12, and now I subtract 2 at the end. My final answer there should be 10. So that's how I would find the missing number. So the nice thing about this one, the rule is already established. We just have to plug the numbers in to figure out the answer. Now that was what functions are. Now once you do a function, you have the ability to graph it. And we start by saying many functions can be graphed on a coordinate plane. Here we see a table, and I'm going to show it here in just a minute, that relates to the perimeter of a square and then how it relates to the length of one of its sides. So on the coordinate plane that we're going to create here, we're going to graph the numbered pairs that appear in the actual table itself. The coordinate plane's horizontal axis, so the one that's going across, is going to represent the length of the side. The vertical axis, the one that goes up and down, is going to relate to the perimeter. So I'm going to scroll down just a little bit here, and what I did is I went ahead, and I already labeled the sides. So we said that the horizontal line is going to represent the lengths of the sides, which are my S numbers. So this right here, my first row is my S numbers right here, okay? The second row is going to represent the perimeter of the square. So that's going to represent all my P, okay? So what I'm going to do is I'm going to plug these numbers in. It's kind of like I'm plugging them in on a coordinate plane. So when I start at the origin, which is 0, 0, and then 1, I'm going to go to 1 where S is. So here's 1 where S is. And then I'm going to go up to 4 and I'm going to put a dot right there. There's my dot. So that's the first number. I'm going to do the same thing here. I'm going to start at the origin. I go over to the right 2 places, 1, 2. And then I'm going to go up, and I'm going to make a dot right there. There's my dot. Do the same thing here. Start at the origin, go to over 3 places, 1, 2, 3. And then I'm going to go up to a 12, which would be right about there. Lastly, I'm going to do a 4. So start at the origin, go over to a 4 on the S, and then go up to the 16, which is right there. Okay. Now I do know that the interval between these are 4, and the interval between these are only 1. And I did that so that way my graph wasn't going off the page. If I would have had this going up 1, 2, 3, 4, then the first dot would have been like right here, and the second dot would have been, well, we would have drawn a line way up there. So after you go ahead and make these points here, then what they're going to ask you to do is actually connect all the dots. So what I'm going to do is I'm going to take this, and I'm going to connect all the dots, start at the origin, and I'm going to kind of connect. And if I make a straight line, you should notice it's kind of going right through all those dots there, right there. And so that's the key to a function. If you have a proper function, you will see that you can go ahead and connect the dots, and it'll make somewhat of a straight line. It might be a little steeper, it might be a little shorter, but it should connect to make a straight line out if you put them in correctly. This is example number 3. It says the perimeter of an equilateral triangle is a function of the length of its sides. Okay, so it's going to be a function. So what it's asking us to do is it's asking us to make a table for this particular function using these particular side lengths, 1, 2, 3, and 4. So we are going to use these 4 numbers. Then they want us to graph the ordered pairs on this particular coordinate plane. And then lastly, you're going to extend a ray through the points to represent the function for all equilateral triangles. So we're going to start, first of all, by making our table. So the side lengths have to be 1, 2, 3, and 4. So over here, the S is going to represent side lengths. So I'm going to put 1, 2, 3, 4. Here are my 4 numbers that I'm putting in here. Now I want to talk about the perimeter. Remember, perimeter means we're going to add all the sides together. And an equilateral triangle means that all of the sides are the same length. So a triangle, there are 3 sides. If one of the sides measures 1 unit, and there are 3 of those, that means my perimeter would be 3 units. If one of the side lengths is 2 units long, and there are 3 of those, it's like having 2, 2, 2, so that means that perimeter would be 6. If one of the side lengths is 3, and we have 3 of those, it's like having 3, 3, 3, so that means the perimeter would be 9. And our last one here, if one of the side lengths is 4, it's like having 4, 4, 4. There are 3 4s, so that side length is going to be 12. Now what I'm going to do is I'm going to come over here and graph this. Now, typically when we make a coordinate plane, a lot of times we'll draw this big huge cross like this. And I put this on here for a reason, because when you do yours on your paper, you don't have to draw this big huge cross right here. The only area that you need to concern yourself with is this top period right here. So rather than making that big huge coordinate plane like we used to, I would go back and make one that looks like this. Just make an L-shaped, because the answers are only going to be up in this corner right here. You're not going to put any answers here, here, or here, so you're just going to be kind of wasting some room. So I would just do this area only. So now I'm going to put those, I'm going to graph these ordered pairs on a coordinate plane. So this is like having the first coordinate plane. So it'd be like having 1, 3. And I'm going to go ahead and graph that. So this would be 1, 3. So I start at the origin. The first row means I go to the right 1 spot. And then the second one would be I go up 3 places. So the dot's going to be roughly right about there. The same thing here. If the side length is 2, and I have, remember, this is my side lengths here. I go over 2, and then I'm going to go all the way up to 6, which would be right about there. Try to make it a little bigger. Next one, I'm going to side lengths 3. So I start at the origin, go over 3, and I'm going to go way up to the 9. So you're noticing that this one is pretty steep. This one's a lot steeper than the one I drew a minute ago on the previous page. And then when I have 4, that's going to kind of go way off my page here. So if I had to guess pretty close, I'd say somewhere right around here, because this would probably be my 11. This would probably be my 12. Then it says to extend the ray through the points representing the function. So now I'm going to go over it with, and if you were to do this on your paper, what I would do is suggest using a ruler to do this, and you just draw as straight a line as you possibly can to extend all the way through those. And so it's that way it looks just like that. That way you have a nice straight line when you extend that line all the way through. And again, the reason why we're extending that line is we're trying to show that this is a function. A function usually it will make some sort of straight line, whether it could be higher up this way, could be a little thinner out this way. So let's kind of review some of the stuff we talked about today. What we're going to do here is we're going to find the missing numbers for these particular functions. So let's say that my x is 4. This is my input number. Let's say my input is 4. What is going to be my output? My output is 1. So noticing here, the number is getting smaller. 4, I went from 4 down to 1. Now, one thing you could do is, well, Mr. Johnson, how about if I do 4 divided by 4? So 4 divided by 4 is 1, and that would work. But does it work for the other rows? If I do 7 divided by 4, is 7 divided by 4 4? No, it's not. That means that this cannot be the function, because remember, functions have got to work for all the rows. So if I start with 4 and I end with 1, I think, doing math-wise here, I think doing 4 minus 3 is probably my best option. So I do 4 minus 3, that does equal 1. Now, does that work for every single one of them? If I do 7 minus 4, yeah, the 7 minus 4, 7 minus 3, is that going to give me 4 as my answer? Yeah, it will. If I do 12 minus 3, does it give me 9? Yes, it will. So it looks to me like the function is you're taking and you're subtracting 3. So now I'm going to take my x, which is 9, subtract 3, and that'll give me 6 as my answer. Okay, let's do the same thing over here for this one. Now you're noticing that the numbers are getting bigger. It went from 3 to 9. My input was 5. My output's 15. That means I'm either going to be adding or multiplying here. And I think if I look at this, it looks like multiplication might be the best thing here. So if I go from 3, what would I multiply 3 by to get 9? And I'm going to multiply 3 times 3. And I do the same thing here. Does it work for this one? If I take 5 and multiply that by 3, does it give me 15? Yes, it does. If I take 9 and multiply that by 3, does that give me 27? Yes, it does. So now I'm going to take 8 times 3, and that's going to give me 24. Here, these are my inputs. I went from 1 to 5. I could have 1 plus 4, but if I do that with this one, 4 plus 4 does not give me 20, so that's not going to work. So probably because I'm making the number bigger, probably means I'm going to multiply. So I'm going to take 1 and I'm going to multiply that by 5 to equal 5. Yep. If I take 4 and I multiply that by 5, does it give me 20? Yes, it does. So now I got to think to myself, what number do I multiply 5 by to get 35? Or another way to look at it is just look backwards. What would if I took 35 divided by 5, that would give me 7 as my answer. Okay. Now down here, they gave us the function already. So now what we're doing is we're just going to plug the numbers in, and then we're going to solve. Remember, this means 2 times 2. So take 2 times 2, and then we're going to add 3. So let's plug the 2 in there. If I take 2 times 2, 2 times 2 is 4. And if I take 4 plus 3, that should give me 7 as my answer. Now let's go back and put another number in. Let's put 3 in there. 2 times 3. 2 times 3 is 6. And then I take 6 plus 3. That's going to give me 9 as my answer. Let's do the same thing with 5. I do 2 times 5. 2 times 5 is 10. 10 plus 3 is going to give me, 2 times, that's 10 plus 3 is going to be 13 is my answer. So you're noticing here, you have, this is your function, and you're doing the same thing every single time. One last problem I wanted to do is take a look at practice set letter E. I'm not going to do the whole thing for you. It's very similar to the one I did a few minutes ago, but just there are a couple of parts to this. It says chemists mixed a solution that weighed 2 pounds per quart. Okay, so we are going to create a table with ordered pairs using the function, for this function where we're going to use the numbers 1, 2, 3, and 4 for the quarts. And already it's going to be number of quarts. So right there, we know we have 1, 2, 3, 4. Okay, I'm going to put a 1 in for this first quart, 2, 3, and 4. Okay. Now I do know that every quart equals 2 pounds. So if I have 1 quart, how many pounds do I have? If I have 2 quarts, how many pounds do I have? If I have 3 quarts, how many pounds do I have? So I'm going to have you fill those in, because hopefully you know that you're multiplying by 2 to figure those answers out. Then once you have those in, then they're going to ask you to graph those. And since this first column here is your input, this should always be the number that goes on the bottom over here. Okay, so you're going to wherever 1 is, and then where would the point go? And then so on and so forth. Then it says here, would it be appropriate to draw a ray through these particular points? Why or why not? In this particular situation, I would say, well, it could go either way. You could say, yes, it would be appropriate because it shows that it's a function. Some people might even say, well, I don't know that it's going to be appropriate because I'm just using quarts only. If you went ahead and said, it's appropriate because that way I know that it's a function, I'll accept that as an answer. Okay. So hopefully this helps clarify that particular problem. I know sometimes in the past that one seems to get people tripped up. So for your assignment for this particular lesson, you're going to do pages 501 and 502. You're going to do letters A through 25. And as always, if you have questions, please do not hesitate to reach out to me. I am here to help you as best I can. So if you have any other concerns, please feel free to go back and watch the rest of this video or contact me. If not, we will see you with the next video.